All right, and very relevantly, this is being recorded to the cloud, it says. So hi, everybody, welcome. Thank you so much for joining us for the first webinar of our Masterclass on Comparative Cloud Technologies. This short course is being presented by IT Masters on behalf of Charles Sturt University. Some regular attendees of IT Masters courses might be asking, where is Guy? Where's Guy? And I've had the torch passed to me. My name is Jack. I'm a course consultant with IT Masters. Little known fact, it's International Women's Day, and therefore it's actually illegal for Guy as a man to be presenting a webinar. So, we're just covering all legal bases here. But in all seriousness, no, I'm helping out with the webinars now rather than Guy. So apologies to anyone who was hoping to see his beautiful smiling face. Hopefully I'll do an okay job. I'll be your MC for this webinar and the duration of this short course. The mentor who's going to be presenting the content is Tim Jones, and I'll let him introduce himself in just a little bit. Hopefully everyone that's watching this is safe and well, feeling good, feeling ready to have a little bit of comparative cloud technology chat go on. So just some housekeeping before we start the course proper. So all the webinars for this course are going to be held at 7:30 p.m. Australian Eastern Daylight Time. So it's for the next 4 weeks, right up until the end of daylight savings. And there will be recordings that we made and uploaded generally within about 24 hours of delivery for anyone who can't attend on any given occasion. And while we do record them, and everyone's obviously extremely welcome and able to access those recordings at any time, we do hope and we do love when people attend the live webinars. It really contributes to creating a really collaborative learning environment. Obviously, we use Zoom for the webinars, as we are all currently on Zoom. We encourage you to engage with the course content through Zoom, through the chat and Q&A functions throughout the entire course. So we ask that you direct the course-related content questions to the Q&A section. And then administration type questions, so dates and times, where to find the resources, administration of overall kind of type of questions to the chat in the support team. So you can either chat to the panelists only or to the students as well, everybody that's in the Zoom room. So you can change that by toggling through the drop-down box once you've opened the chat log and select either everyone or hosts and panelists. There's usually, we often have like some really, really experienced and knowledgeable attendees in the webinar as well, who are extremely helpful a lot of the time with queries that other students have. And their insights can actually, provide a lot of addition and, some kind of augmentation to the course content as well. There will be Q&A sessions as well at the end of the webinar, but there might be some particularly relevant questions throughout, which I will bring up with Tim at various points throughout the course, or he might invite some questions during the discussion. The Q&A section is always there as well for that course content related type of question, if you have any of those. So for anyone who is, I know I mentioned, some people in here might be repeat attendees of IT Masters and Charles Sturt Uni short courses. But for people who are new, who've never taken part in one before, firstly, welcome. Thank you so much for coming along. We're really, really happy to have you here. So IT Masters is a training organization that is partnered with Charles Sturt University. And we work together with them to create and deliver a number of postgraduate courses, so graduate certificates and master's courses. We market the courses on their behalf as well. And so part of that marketing is, just giving away some of the content for free like this. We believe that the content speaks for itself that we provide. And, if we do a good enough job providing these short courses and engage people well enough in that, then students will be encouraged and enthusiastic to enroll in the full course if that's their goal. And if that's not your goal, or regardless of what your goal is, we hope that the course itself will just be a really useful and rewarding exercise overall. Hopefully you can learn some interesting information that's relevant and, sort of something a little bit new or a different insight, have some fun, and ideally also, make some connections with some of your fellow students who, may be or may go on to be your colleagues or, other people in your field as well. So we also have Hannah tonight, who is here in a moderation capacity for IT Masters and is also being helped out by Kit in the moderation and kind of admin type roles. Hannah is responsible for the learn.itmasters.edu.au website, and that's where you can find the materials that you need for the course other than the webinars. So links to the topics, the discussion forums, quizzes, and so if you've got any questions tonight or later on, you can get in contact with us using the details on that page. And finally, thanks very much for listening to me, but I'm going to hand over to Tim Jones, our fantastic mentor for this series of webinars. Please make him feel very welcome in the chat, and take it away, Tim. Feel free to introduce yourself and the content. Thanks very much, everyone.
Thanks very much, Jack. Much appreciated. So welcome everyone to the first week of Comparative Cloud. So so we'll be covering a fair bit of content over the next few weeks, and I'll go through what it is that we're covering coming up. Now, very first thing is just to let you know, when we reach one of these orange slides, it means we're at a section break, and that's where we'll just take a breather for a moment in case there's any questions that are pertinent to the section that we've covered, and we can go through and deal with those. So if you have any questions, use the Q&A function. Happy to get into any meaty questions that you might have around those things. But to get started with, here's my information. So if you have any personal queries, happy to field those. If you want to connect with me on LinkedIn, I'm more than happy to connect with you as well. So from a personal background, I'm a long time in IT. So I started a bit over 30 years ago in IT, and I've spent most of that time working through more the infrastructure space and the application space, but there's a lot of backwards and forwards that goes over that time as well. Over the last few years, a lot moving along with the industry as well, continuing to keep up to date with the education side of things. I've also kept up to date with the way that the industry is moving. And so a lot of my work has been involved in architecture, in particular around the cloud space and modern applications. And so that's, so my day job at the moment is, the term is as a global enterprise architect for Dell, working with some of Dell's largest customers. At the moment, I'm working specifically in the telco space, but I've previously worked in defense, done a lot of work in finance, government work, all sorts of areas, but telco in particular at the moment, and changes that are coming through with 5G and planning for 6G in the future. So a big reason why I'm here now, though, is a love of learning. Right? So I'd like to keep learning. You can see in the bottom right-hand corner here a bunch of the industry certifications. So through my early mid-career, the way that I found to move ahead with my own career was through industry certification, and I leveraged off that to get my university and tertiary qualifications. So I qualified in 2007 with a Master of Information System Security through IT Masters, and I started with them in 2018, starting to work in the mentoring space. So starting off as a marker and launching into delivering courses for them. Again, in the courses I deliver are in the cloud and the modern application space, microservices. So if you're interested in this sort of topic stream, this is the sort of area that you'll come into with a Master of Cloud Computing or as an elective for one of the other master's subjects. So where we delve into a lot of the reasons why these things happen, but also there's a fair bit of technical knowledge and hands-on capability that's part of it as well. All right. So what we have here, sorry, I need to update the the link on the screen, but that'll be in the slides that go out. Is first of all, if you have any questions that that come up, that what we have is the IT Masters shared site. So thanks very much, Hannah, for putting that up. So in the chat link, and I'll make sure that's in the slides later on, is the link to the course information. And in there we have both a discussion forum, we have information about the course, we'll have all of the slides for you to access. There's quizzes on a weekly basis. So the first week's quiz at the moment is up. That's all based upon the content which is in this course that we're running through at the moment. And there'll be an end of course exam as well. So a key, again, as Jack was mentioning earlier, to get the most out of the course is to be interactive. So the asking questions that we have coming up here, and we'll answer as many as we can. I can see that a bunch are flowing through at the moment, but also to be involved in the discussion forums as well, because there you'll find a whole bunch of like-minded people that are very likely at the same career point as you, looking at further education options and the ability to further themselves professionally and personally as well. So the idea though is that it's very much a safe collaborative space, and we'll be making sure that it stays that way. So stick to topic. You can have as much banter as you like, but make sure that it's the sort of banter that anyone on the other side would like to receive. All right. So on the other side of that, we also have the admin team. So we have Hannah and Kit and others that are involved too in the back end, doing all of the hard work for the admin side for running this course. And we've got the ability for people to access the admin team as well if there's any problems. Now, I'll go through in a minute. There's been a few questions around the AWS course, and I'll cover that off in a moment. As part of this, so one of the questions that came up was getting bonus credit towards a university degree. Right, so whether it's a master's course or something else, if you cover off 3 of these masterclass courses, you'll gain a credit towards one of the master's level courses, effectively a master's level course credit that goes against your record. So anyone that's keen in that postgraduate level study, it's a great introduction to getting a leg up on actually starting that as well. And the emails haven't been sent out yet. So if you haven't received an invitation to the AWS course, that'll be coming tonight or tomorrow. So it just takes a little bit of time for it to go through the system, for us to collect all of the email addresses, because I think we had like 2,500 or something like that were signed up for. And what that means is once you receive that, I'll go through at the end of the course what things look like and what you can expect from that. But you'll have access to that learning environment and the ability to do hands-on technology learning with AWS as well. So that again is zero cost. So finally, just a couple of questions that have come through on the chat as well is that the quizzes as well as the exam will be available moving forwards, right? So this will be something that will operate as a MOOC or a massive open online course that will be available on the IT Masters website moving forwards. So the recording, the slides, and all of the other bits and pieces will be available there. The only thing which is time boxed as part of this is the AWS course. So the AWS course will be available for anyone who joins up to July 2022. So if you join the course after then, you won't have access to that course. So a good bonus for people that have come along, especially to the live session here. You get access to some really great content from AWS. All right. So what we'll be covering this week is we'll be going through an introduction to cloud technology. And what we mean by this is going through some overview of what we mean by cloud, how everything ties together, the course information that we're covering, etc. So this week, it will be reasonably academic, the information that we're looking at. So going into some definitions and some information around how things work. In following weeks, we'll be delving more down into the specific technology itself. And as it's a comparative cloud course, we'll be looking at different options from what are termed as different hyperscalers, which again, we'll go into a bit of a discussion around those, or other providers at the same time. So this week, this is what we'll be running through. I won't go through each of these, we'll get to them in time, but we'll be covering off this, and this information again will be available later on the Moodle site, the IT Masters site for the course as well. All right, so final thing as part of the introduction, again, just reiterating one of the things that people are really keen on, what you get out of this course. So again, you get a 1/3 credit towards a master's level course or graduate level course through IT Masters. The exam will cover information from all 4 weeks, and there'll be weekly quizzes that will also test how you've gone through the week as well. The AWS Academy site, again, will be available to everyone until July 2022. So if you signed up today, you'll continue to have access to the site for that time. And as I'll go through a little bit later, you have access to full sort of sandbox environment. So if you're doing further studies around AWS or you want to have a play around with it, you can play with the environment as a whole up until the end of July, and there's no cost to use that sort of cloud environment. The other side of things is you will get a certificate that looks like this. So one of the sort of things for that you can share on LinkedIn, show your capability to put into your resume, curriculum vitae, etc., as well as a badge from AWS that you receive as well. So all of that will be available to you. And if I just bring this over, this is what things look like when you have when you get the Credly badge. So if you complete the course, you end up with a badge that looks like this, and from here you can go in and share that information out directly onto LinkedIn or another platform, Twitter, or anything like that. So really good platform for both sharing, for keeping track of certifications, but being able to push through, share information through your CV, or for roles that require you to prove that you've got some cloud capability, that sort of thing as well. So, so quite valuable. So we've reached the end of the introduction section. So I've been trying to keep track of the questions. Hannah, is there anything that I haven't covered so far as part of the introduction for the course, etc.? All good? Excellent. Thanks, Hannah. Nice one. All right. So,
Tim, I was just going to say there are a couple of more general questions in the chat that I might just read out just as we get started, or let me know if you'd like to address them slightly later on. But I'm interested in your opinion. An anonymous attendee, somebody very mysterious, has said, have you come across any person or company that's holding back on moving to cloud, and what are the reasons that hold them back? As well as another anonymous attendee, or perhaps the same one, asked if the major core banking systems are allowed to be hosted in the cloud platform in Australia, Would you like to answer these questions now or slightly later in
Yeah, no,
the
so this
webinar?
is pertinent to what we're talking about at the moment and the preamble that I gave around these sort of things. So first of all, in regards to holding back on cloud, there's various reasons. So in a lot of cases, and we'll go into a bit more detail a bit later as to the reasons why people do move to the cloud. But one of the things which people look at is their readiness or capability to take advantage of modern technologies. And that not only requires a technological change, but the technology is often one of the simpler components of dealing with large-scale change within an organization. You need to have the people, process, and culture in place to realize any large-scale adoption. So tying that through as well with the finance question, I was working as a cloud architect at one of Australia's large four banks a few years back, and there was an edict that came through from basically the CTO and the CIO that they'd be moving everything to cloud within the next couple of years. And the problem is that it just wasn't realistic from a culture perspective, from a skills perspective, from a technology perspective, from the way that the broader business worked with things, it wasn't realistic. At the time, back in 2018, it also wasn't realistic from a compliance perspective. So APRA is one of the major compliance and regulatory bodies within Australia for dealing with the finance sector. And the APRA in 2018 wasn't keen for companies to move systems of record or large scale systems that record customer data to the cloud because they couldn't be sure of the systems continuing to be up or that they would protect people's privacy, etc. Excuse me. That sort of thing has changed over the last few years. Right? So all of the banks are very much all in on the cloud technology capability. They still have data centers. They still have lots of systems that are in there. They still run mainframes. They still run Unix systems, which aren't supported by the cloud, like AIX and other platforms. There's still a whole bunch of AS400 platforms and other older technologies that aren't able to be cloudified. But there are a lot that's moving to the cloud, including systems of record. So culture, people, and process, to come back to the original questions, is the major thing that holds companies back. And it's from a banking perspective, they're full steam ahead if the technology supports it within the organization. So
awesome. Thanks so much, Tim.
No worries. Okay. So the delving into some of the detail of what we're looking at now. So what is cloud? Right. So my partner wanted me to use her term for what the cloud is. She likes to call it Bezos's basement. Right. So you're basically just putting your compute systems in someone else's basement or data center or something like that. Now, that's a simplistic term, but what we're actually looking at from a cloud technology perspective is most generally you're accessing some data processing or data storage capability over the internet, or you're able to access it over the internet, or you're using internet-based technologies such as web technologies to access systems in the back end. So it's a very broad range of what is the cloud. Right? So the cloud is not any particular one thing. It's something which is quite broad. Now, when people talk about the cloud, they're often talking about cloud service providers is one of the most common things. And you have companies like AWS, Azure, and Google Cloud Platform, or GCP, as the largest cloud service providers, and they're what we call hyperscalers because they're able to move to extremely large scale web-based application systems that you can grow within their environments. But the cloud can encapsulate systems potentially in your own data centers, because it can meet that very broad definition of how we put these things together. It can also be systems that are software as a service. So things like Salesforce or other platforms that are accessed over the internet. So again, the definition is reasonably nebulous, but what we're looking at is the ability to usually access using web-based technologies again. Right? So the ability to control things either through a web portal or APIs that we'll go through a little bit more detail in a few minutes. So part of that, of what we're looking at, and just as an aside before I go into that, one of the things as a academic institution, right? So we're part of Charles Sturt University. One of the things that you'll see on my slides is basically an attribution to where I've taken information from. So just again, as an aside piece, from an academic perspective, if you take things from the web and just put them into your documents, that's plagiarism. If you take them and put an attribution in there, that's working in academia, right? So there's a fine line between the two, but it's important to have an understanding around how references work and making sure attribution is set. So I just wanted to be clear around what that looks like from a perspective of dealing with academia. All right, so what do we have as cloud? So there's a lot of things for the way companies deliver capability to their customers, right? And the way that they do this is often through an as a service offering, right? So you'll see all of these things, such as we have main components here, such as infrastructure as a service, platform as a service, function as a service, and software as a service. We'll go through a little bit of an explanation of that in about 10 minutes or so, but this isn't an exhaustive list. So one of the things that we're working with at the moment for a bunch of our clients is something like container as a service, where you're providing container or microservices capability to clients on a container consumption service. And this is one of the things that the large hyperscalers provide as well, and that you can use within your own environment. So one of the things that we also delve into from a cloud perspective is what we term as cloud native applications. All right, so within normal applications that we would have had 15 years ago, often within an organization, there's what's called a monolithic application. And what this is a large application that to change any one small piece, you need to test that the entire application works together and that everything operates as expected. Excuse me, I'll just wet my whistle. So what we have is these large scale applications require a lot of testing to implement even the smallest change. All right, so a large ERP system or enterprise resource planning environment such as SAP or Siebel as a customer relationship management system, or a large piece of software that's been built in-house within an organization. So these are all examples of monolithic applications. And to make any changes to those, you need to, again, test everything. You need to do a full release cycle, and any change requires, it might be months, it might be a year, it might be multiple years. So again, when I was working in the banking environment, if we wanted to make a change to mainframe systems, we were looking at a change cycle of 18 months to 2 years to get any changes that we put in place in there. So that really constrained what the business could do from a flexibility standpoint. If there was an opportunity in the marketplace, it meant that they're unable to meet those capabilities for a couple of years. And many banks are still constrained by a lot of these things. They have new modern systems that are put as band-aids on the back of their large-scale systems, because the big four banks are all still run with mainframes in the background, but there's many interfacing systems that allow them to be much more flexible and respond to market needs much more quickly. At the opposite end of things, the way that we're moving with modern applications, we have microservices. So what microservices are is that we take all of the very small components of an application. That might be the way that we respond to a client with a web page for a particular request. It might be doing the authentication for users to access the website or something like that. But we break it down into individual components, and we have separate testing, development, and release staff that work within that one tiny area, and very clean, well-known APIs, or what we term as application programming interfaces, that allow us to know that the application is going to work as expected within the broader application set. And part of where we see these sort of things is we have application sites such as Netflix, which use microservices to deliver your TV experience that you have with Netflix. So the way they operate is they're 100% sitting within AWS data centers and AWS edge sites for content delivery. And when they make a change, they're able to change an individual component, and they're also able, off the back of those very small components that they have within the environment, have a very granular build out of capability and scale to their clients as well. So it's so as an architectural pattern for deploying applications, it means that it's much easier to deploy capability. You can respond to changes much more quickly, and you have a much more robust and change resistant, or a system which is unlikely to cause problems in a larger production environment. So again, that comes back to application programming interfaces of how these talk to each other. And from a web-based technology view for these cloud-native applications, we have most commonly a REST interface. And this API, basically we're using HTTP type technology. So regular web traffic that we're sending backwards and forwards to application stacks to get them to do certain things or to pass information back to us. Right? And this is the way that a lot of modern applications work in the cloud space, or you can build these sort of capabilities in your own data center as well. So it's a capability which is, again, predicated on the idea of having an application which is robust and able to respond to client needs very quickly. You can get things out into the marketplace rapidly, but has some deployment methodology as well that makes it much more robust and less likely to fail. Finally, around that, with, looking at cloud native, the flip side again of that is what we see is multi-cloud is a reality. We spoke before about why it is that certain companies wouldn't move to the cloud and or may not have moved there yet. What we're seeing in every single large organization at the moment is multi-cloud is a reality. So not just moving some workloads to AWS or something else, but moving things to multiple clouds. So using GCP, using Azure, using AWS, using software as a service. So lots of capabilities. Excuse me. So what that drives through to as well. So we've got cloud native applications that we can build from the ground up. But what do we do as an organization if we're looking at this sort of technological capability, but we've got a whole bunch of legacy applications? Like I was talking about before, within the banking environment, you have a large number of applications that are running on old technology that might not have been updated for 10 years, are still running in the environment. And you need to look at how you're going to deal with that application, especially if you're looking at doing a large scale migration to cloud environments. So this is where we look at the 7 R's for how we map and plan for the architecture of these applications, especially around the cloud migration space. And we use this type of methodology all the time for having especially a quick cursory look for planning for cloud migrations. So we're looking at retire, replace, relocate, replatform, rebuild, reuse, or re-architect the platforms. And if we want to build a cloud native application, we need to go to that step 7 type environment where we're re-architecting the application and moving along. What I've seen a lot of companies do, again, is there's often a view that the company wants to move to the cloud, whether it's because there's perceived savings or that someone wants to be seen as someone making change within the organization or anything like that. But we see a lot of companies just take virtual machines from a data center and move them directly to the cloud. So no translation, just basically relocating them rather than remapping them or remaking them or doing anything else to the platform other than moving it directly to the cloud. Now, there can be very good reasons just for moving virtual machines to the cloud without refactoring or making them cloud native or anything like that. So if you've got a data center exit and you no longer want to own or manage a data center, it's a great move. If you want to get the operational benefits of not having to manage physical hardware for certain systems, or you want to deploy them as a software as a service platform for your clients or something like that, it makes perfect sense. But what we see is lots of companies going through and saying that they've had a successful cloud migration when they've just basically rehomed their virtual machines again into the bottom of Bezos's basement. And so they haven't done any true transformation of the systems or environment. And often we see that as a response to some sort of edict rather than really thoughtful planning of how you manage an organization's technology. So that's what we're looking at with cloud. So any questions around the cloud space? So anything that you've seen pop up in the questions or chat, Jack?
I see now that the question that I previously asked was actually particularly relevant for this little orange slide. Yeah, well, we've got a couple of questions. I think you may have covered some of this, but about what kind of incentives there are for companies, including telcos, to invest in cloud technology. Or I suppose on the flip side, if there are going to be disincentives as well for any reason. Yeah, do you have any and then yeah, there's a couple of others in the Q&A, but what are your thoughts on the incentives or disincentives specifically for some of those companies?
Yeah, so it's around that. It's reasonably broad. So the incentives for investing in cloud is often moving towards greater efficiencies and following the same line that IT has been following for the last 20, 25 years of IT departments have continued to be told to do more with less money. And that's been continuing all the way through. And so the expectation is that IT budgets, where possible, will go down rather than up. All right. So the incentive we see from a strategic view of moving to the cloud is, and we'll cover this in a minute, is delivering more efficiency and faster speed to market and that sort of capability. The disincentive side is in certain use cases, you don't have as much control as you would have previously to your environment, and you may need that sort of thing. Specifically in the cloud space, one of the projects that I worked on with Telstra was delivering a bare metal as a service cloud platform. So a different type of cloud platform as a joint venture between the company that I worked for and Telstra to deliver to the market essentially physical machines that people can utilize at a different level to general cloud infrastructure. So even if you're looking at specific requirements, there's often companies that will have some sort of model from a cloud perspective to meet it if there's enough people that look at all the way down to looking at cloud environments that can support mainframes or other disparate systems. But from a telco specific perspective, one of the biggest disincentives is that is one of the reasons why compute is really important to telecommunications companies right now. And that's the development of the mobile edge, so edge computing within organizations. So the ability to have data and applications available to end users and have very low latency links to those people. So we see a lot of edge sites, especially around things like content delivery. So the ability to get access to your Netflix from anywhere in the world and have very fast access of that firing up quickly for you. But the expectation over the coming years with the changing technology trends that we see in telecommunications is there's likely to be needs to have low latency application links into a broader network, especially within cities. Now, what we don't know is what those exact applications will look like, but all of these things tie together because an example application could be using augmented reality. You could be walking into a supermarket with Microsoft HoloLens with your synced shopping list, and the AI will guide you through the store with overlay of all of the products that you need to pick up off the shelf and map that through for you, or other means of doing augmented reality for gaming through the streets or anything like that, or the ability to have robot cars and have live information around traffic accessible. So all of these can be things that drive the need for low latency links, which, coming back to why cloud, is the need to have these compute capabilities not in central data centers, but in these edge locations. And again, that is often driven by telecommunications companies, which have very distributed data centers or data closets that they can put capability into. Does that? I'm not sure whether that covered it, but I think that sort of covers the crux of it.
I think it leads in really well to your next kind of topics as well. Thank you.
Yeah, awesome. Thanks, Jack. So that looking at a high level, why do people want to go to cloud? And so this is what we see from a bunch of people that look at why you'd want to move to cloud. Now, the problem with this is they're bad reasons, right? So they're not good reasons to move to cloud. So yes, you can potentially lower costs, and the CIO might have a directive to move to the cloud, and it's possible to have regulations or compliance easier to deal with in the cloud. However, these aren't reasons in and of themselves. If all of the thought that goes into it is a CIO saying, I want to move to the cloud, that's not a well thought out approach to dealing with cloud. All right, so all of these can be part of a broader reason and a broader plan to move to the cloud, but it's not the be all and end all. So what we look at from the good reason sort of perspective is, as I was mentioning before, we have much faster time to market. Using cloud technologies, we can change the way that we deploy and manage applications so that we can instantiate change into a production application in the same day. We don't need to wait days weeks, months, and as I said, in some older systems, years to actually deploy change within our environment. As soon as change is required, whether it's because of a business need, a financial imperative, a patch, or something else, we can deploy change very quickly and using modern deployment techniques in a way that is not only covers off our risk perspective, but we can actually test particular change and things like that at the same time. All right, so what we see with sites such as Facebook and Twitter is that they will test new versions and new interfaces of their website and their interface and their capability on certain users. They can select a subset of users because they've got smart interfaces with the way these things flow into the environment. If you were dealing with a traditional monolithic application, you don't have the ability to have that piecemeal view of how you deploy an application. So we also end up with the more flexible solutions. So again, if we need to add a new component, it can be slotted in. We don't need to change the whole application. We don't need to change the broader architecture of the application. We can add capability as we go. And that's also really important from the perspective of how you deploy an application itself. Like, what do you do on a day-to-day basis to deploy your application? You want to be able to pick up a particular component and add the functionality that you can over time and plan that out. Make sure it's working very well for the 80% that you need to go live, and then continue to add functionality as you move on. You don't need to boil the ocean to deliver a single application. We also have more efficient way that we deal with these things. So especially in my space, coming as an infrastructure person, dealing with IT plumbing, managing the bits and bytes that go around data centers and things like that, the traditional way that you have people look after infrastructure and the way that these systems work with each other is you have a whole bunch of administrators. You have a storage administrator, you have a hypervisor administrator, you have a network administrator, you have a server administrator, and so on and so forth. The way that we look to deploy a lot of technology and manage it from an operational standpoint moving forwards is that we have cloud administrators instead, that we manage our infrastructure through APIs, through scripts, through portals and interfaces. We don't go in and manage these components by clicking on individual servers and going into to manage them on a piece-by-piece basis. So our cloud administrators can deal with a much larger fleet of equipment because not only are they able to make changes or updates or anything like that to a larger range of systems on the fly, often they don't deal on an individual basis with any of the components because everything can be deployed as digital assets. So we can use, if we're deploying an application with microservices, we can use containers with Kubernetes, Helm charts, and that sort of thing. So the sort of detail and information that we go into the microservices course, but the ability to deploy entire application stacks with digital assets that can be tracked for change management and that we can keep in something like a platform like GitHub. All right, so it allows us to manage those things in a much more seamless and holistic way from a single person perspective. And finally on this, they're highly scalable. So if Netflix was to deploy their own application stack, they would have never got off the ground. They would have stayed as a DVD company that they were originally. All right, so you couldn't deploy their capability as a startup because you're unable to scale. Like, how do you, every time you have more users on a Saturday night that tried to Netflix and chill, they go through and start things up and someone needs to install a new server to deal with the extra load. All right, so cloud computing is imperative for web scale applications. The ability to rapidly increase load and the ability to have the complexity hidden from the initial application management piece, but to be able to build a very comprehensive application that can meet client needs really quickly. All right. As an example, again, there's a guy in Los Angeles that runs just a simple API for weather so that anyone on the web can access his weather app for getting information from Los Angeles. He gets, as an application piece, he gets 2.5 million calls that comes through to his API on a monthly basis. Right? So in a traditional sense, he would have a whole bunch of things that he would need to have as part of his environment, but he runs it with serverless code and an API gateway and some other capabilities. And it costs him like $10.50 every month to keep that up and running. So not only Netflix, but on a very small scale, cloud enables really scalable applications and capability. All right. So before we move into major providers, so just having a look here. So one of the questions that came through before said that Unix technologies in AS400 are not available in the cloud. Please explain why not. So one of the reasons that we don't see these things in the cloud is, when I say we don't see them in the cloud, we don't see them in the hyperscalers, because there's not the market for it. The reason that we see big growth in the hyperscalers is that they are based heavily on Linux technology and the capability to run some Microsoft technology, because that's endemic in large enterprise organizations. They need to run those capabilities for virtual machines. So they're running on generic hardware. So if you're building a brand new application, you can build it using those capabilities. There's no reason that you need to build it on mainframe or AS400. So as such, you don't see any brand new implementations going on mainframes, even though they're quite capable, and the IBM people that I dealt with over the years were always keen to try to get more and more people to write applications for their platforms on AS400 or mainframe. But there isn't the market for new applications to go on there. Now, there are specialized providers for certain segments of the marketplace. So as an example, from a banking perspective, the bank that I worked for, they had a infrastructure cloud type arrangement. It was termed as that. They had access to systems remotely as more sort of a managed service capability, but they had a private cloud type capability, and still do, with AS400s and mainframes sitting within that environment. So it's absolutely capable to run those sort of systems, but it's not a general purpose thing. We don't see anyone rushing out to build their new Instagram copy application with a AS400 backend. It just doesn't happen. All right. So, and another one just come through. So if you were trying to run, say, a Windows 7 environment in Amazon, do you select that as part of the cloud provider setup, or do you upload a Windows 7 VM? So generally speaking, like it's possible to copy your virtual machine across to the cloud. And that's the way that a lot of cloud migration works. So you're basically copying virtual machine images to the cloud, and you're able to pick them up and run them, whether that's running as a direct virtual machine, or whether you're using something like VMware on VMware Cloud on AWS or something like that. Now, from an individual's perspective, though, there are workspaces. So there's essentially VDI, or virtual desktop infrastructure, that's available in all of the cloud providers. So you can get a Windows environment. I'm not sure about a Windows 7 environment, whether that's still supported, but you can certainly get a Windows 10, Windows 11 environment that's running in the cloud with the applications you need. If you needed something specific, like you needed to run Windows XP, they're not going to provide a really old version for you, and that's where you would need to do something like have your ISO to run a install or do something else. All right. So anything else that I need to cover off from that section, Jack?
No,
No?
power ahead. Go for your life.
Awesome. Thank you. All right. So what are we looking at from the major providers? So just this is opinion, right? So I'll just preface this that this is my view of the marketplace, and this is and what I've seen. So AWS was built out of their own technology capability for running a very large, scalable website. So their own Amazon website. They built the storage capability and EC2, what they term as their virtual machine technology off the back of that, and started selling that around about 2008 or something. And they were the first cloud compute company that was doing it at scale. Right. So there was lots of companies prior to that where you could host web servers, you could host servers within someone else's data center, and that sort of thing, but you were still responsible for dealing with all the management. You were just basically hosting the system in there, or you would have a managed service that would do all of the regular things that you would do to a server, but you would just pay someone else to do them. The AWS was the first to bring a very different way of people dealing with that technology and how they would consume it, and brought around the paradigm of how you build web scale applications as well. So it brought that capability that Amazon had for running their own website and having a large scale access to other businesses. So it opened up business opportunities for the way that people could operate as well. All right. What we saw with Azure is they followed up. So they've continued to be very strong. So they're a very strong second place, and they also leverage a lot of their capabilities in the Microsoft tool space. So the servers, the Active Directory, and in particular Office 365 and their mail platform. So remember, we have software as a service as part of the cloud, and Office 365 and the ability for people to get access to their Outlook email is one of the biggest software as a service platforms in the world, especially from a corporate perspective. So they've got a massive footprint just based upon that software as a service play, but they've got a general hyperscaler, large scale footprint as well. GCP, Google Cloud were kind of the last major one to the market, and they came in, and where they've really heavily moved towards as well, based upon the type of technology and capabilities that they've got in the back end, has been very much around their data processing and data science type capability, the ability for people to run data models, AI systems, that sort of thing in their cloud environment. But as well as these three, there's also there's the Alibaba Cloud, which has cloud environments here in Australia as well. There's a bunch of private cloud environments. So Dell has one called VirtuStream. Dimension Data have their own cloud environment, and various other businesses do as well. And so the same throughout the world. But when you're talking about cloud and you're talking about hyperscalers and the ability to create cloud native applications in a cloud service provider environment, what people are talking about most is one of these three platforms, and most likely one of the first two. All right, and so moving on from that, what we have is just looking at what technologies make up a cloud provider environment. So if we go back again to what we were looking at earlier with the different types of systems that we have as part of a cloud environment. So we have infrastructure as a service, and this is where we're looking at the comparative piece. And we have EC2 on AWS, Azure VM on Azure, or Compute Engine, which is in GCP. Now, on all of these platforms, so these are just examples of a particular type of infrastructure as a service. Not an exhaustive list, but it's just an example. What you can do with these on each of these platforms, they're essentially just virtual machines, like you would run in VMware, and you can actually convert your VMware or Hyper-V or OpenStack platforms to run that. So if you're looking at a platform as a service, one of the things that people use, especially for cloud native applications, is moving to NoSQL databases. And so this is what we call a primary key database. So a different way of storing data to what we would do with a relational database. Relational database is really good for having very strict relations between everything that you're putting in there, like customer information, orders, etc., is great. But when you have really large scale databases like gaming systems that have 5 million users, and you want to quickly find a particular user and what they've been doing lately, you want to have something like a NoSQL database or a primary key database. And so that's one of the things which is available on all of these platforms as well. If you're looking at non-hyperscaler, this is looking something like MongoDB or Cassandra, and they're quite similar in underlying capability to something like Cassandra. So DynamoDB for AWS, Cosmos DB for Azure, Cloud Bigtable for GCP. So we come across to function as a service, right? So this is where we term as serverless, right? So just to keep in mind that when we're talking about any of these technologies, infrastructure as a service, in particular, when we come to talking about serverless, in the back end, there's always still a server, right? So we're not just connecting into the cloud and pulling things out through magic. Underneath everything, there's always an actual physical server that something's running on. All right. So the reason I say that is just to be completely clear, because I have had conversations in the past with some non-IT people that haven't fully grasped, especially when you start to get into technologies that have a name which doesn't make sense for that. So function as a service or serverless. We have Lambda with AWS, and so this has been popular for a number of years. You can even go down and program your own Amazon Echo to do certain functions and things like that through Lambda for you. What this means is you pay on a per function call basis rather than running an application long-term. So if you only call a function 2 times a month, it's probably going to cost you 5 cents to run, to have your application running and be available for use. So if you're running that on a virtual machine, right, so EC2 in AWS, the minimum cost for that is probably like $30 a month to run a server and have it available, sitting there just waiting, listening for calls coming in. All right, so it's both cheaper and gives us again a different microservices architecture methodology for how we get access to that. We have Azure functions and the Google Cloud functions with GCP. And then finally, we have software as a service. I mentioned Office 365, there's G Suite or Google Mail, but a large player in that space is a company like Salesforce. So this is an area which has grown and grown over the last 15 years to be one of the largest companies out of Silicon Valley in a very long time. So they're a massive force, and that's fully, everything's available as software as a service, API calls, the ability to pull information through. All right, so that's the end of the cloud overview. The last thing that I wanted to go through was just a quick overview of what the AWS learning environment looks like. Before I launch into that, Jack, was there any questions that I needed to address. There'll also be some questions available at the end, but anything that I need to look at now?
I think the one question that I think is probably the most relevant now, and we can come back to some more of the other more specific questions later in the Q&A session at the end, but Kashif asks, which one is a good starting point, AWS, Azure, or GCP for entry level? I feel like you might be about to answer that anyway, but go for it.
So the good starting point is if you've got any experience with any of those platforms at all, or if you work for an organization that uses them, I would steer towards something that either you have some prior experience with, or that you have some reason that will benefit you from a professional standpoint, or something like that would be the first case. But if you're coming in completely fresh, they're all very much synonymous with overall capability. It's very much an arms race between all three. As soon as there's a product or capability that is quite popular on one platform, if the other platforms don't have it, they will bring it up. So getting started, it isn't a problem between all three. Now, from a meta perspective of which you should go for, I'd suggest AWS has the biggest market share. Right? So they learning skills on that platform, you are going to have the most marketable skills, easiest to find a job. But again, if you're working in an area which is a little bit more niche, so for example, that you're working with Office 365 or Active Directory or something like that, Azure might be more pertinent. If you're working with data models or something else, then GCP might be better. Now, having said that, the thing that you will get access to once we've got everything set up from a email perspective, the email should be coming through tonight or tomorrow, you'll have access to AWS as part of this course. So I'll run through that now. Was there any other questions, Hannah? Or is that a good point to launch into the demo?
I feel like it's probably a good time to keep going into the demo and make sure that we've got plenty of time for questions at the end as well.
Cool, thank you. All right, so when you launch into so this is what it looks like when you get into the AWS learning environment. So you'll have access to AWS Academy Cloud Foundations, and this is the course view. So within here, we have modules, and you have access to the full video display, so you can go through all of the content to learn as much as you want around the AWS technology. And if you go through the course, these areas where you see this little empty hole down here, you need to complete all of these sections to complete the course and get the badge that I showed earlier. So to graduate, you need to get 80% on all of the tests. You can do the tests as many times as you like. So there's no simple pass or fail. So there's no problem even having an attempt at something, even if you're not sure about it. You can go in and relaunch it as many times as you want. So don't stress that you're going to bomb out or anything like that as part of it. The other thing that you need to complete as part of it is in some sections, such as down here, we've got labs. So to run a lab, we go in to the lab environment. That loads up. I feel that because I'm in student view, just bear with me. I'll exit student view because I think that is what's causing it not to work correctly. So you see some extra things in here. Don't worry about that. But if we come back down to here, actually, I need to go in as learner. My apologies. The view wasn't working quite right. So if we come through here, we can see that I've completed all of these components in my own running of this lab, which gave me the badge. But what we can see is it gives us full instructions on how to run the lab, everything that you need to do as part of running it. We can click on the Start Lab button. And what this does is it actually creates an entirely new AWS account for us and sets up the lab environment with all of the back-end capability that we need to have running. So all of the networks, all of the virtual machines, etc., that we may need to have part of the environment, it runs away and gets it up and running for us. All right, so as this is going, the important thing to remember is just to keep a view of how it is that we're running through the actual exercise, etc. All right, so here it says that we're creating the lab at the moment. I think that I should be able to do this. Once the lab has completed starting, we should be able to press the AWS button, which logs us into this brand new AWS account, which has been configured with all of the components and access that we need to actually run the lab. So from here, we can run this in one window and we can have access to run through everything that we're told. So you can see here, we've got fully functional AWS. We're using the actual live console to do everything. We can see that we've got a bucket that's here. We can go through and do things like create a brand new bucket. And it's failed for some reason, but yeah, we can do all of the bits and pieces that we need to. We can also interrogate the whole site. Now, what will happen is when we have completed the lab, when we think that we've gone through and done everything, we can go through and click on the, there's a button that will allow us to, where is it? I think that I don't have it because I've already completed this, to basically mark the mark what we've done. So we can go through and click the submit button once we've completed the whole thing. And we just need to have completed 80% of the things that it's told us to. So it has certain things that it checks within the AWS account that you've set up, and that it goes away and runs that. So you've got 4 hours to run the lab environment. So if you don't complete in that time, it'll reset the account and you'll need to start from the beginning again. But 4 hours is heaps of time for all of these things. The longest one is likely to be completed in 60 minutes or 90 minutes. But yeah, if you need to go and have lunch and come back, there's plenty of time to do that too. But if you go to sleep overnight, you won't have your work available in the morning. Now, one of the really cool things that's also available for this, if anyone's looking at learning some extra things, now is the ability to go through and have access to the sandbox environment. So if you just want to play around and create some virtual machines, you want to create some load balancers and other bits and pieces, then you can go through and do Start Lab here, and you can just completely play away to your heart's content. Now, just to let you know, there's, again, zero cost associated with this. You're not billed for this. There's no cost associated with it. But you will have limitations on the number of and type of virtual machines and other instances that you can launch. So if something fails to launch, it just means that it's not allowing you to do it. So it'll tell you in here the type of things that you can actually launch and what it'll let you run in the environment. So you can run different types of virtual machines or EC2 instances and RDS and other components. So, but it's a really good capability. And so if you're looking to learn some cloud technology, both the videos are very well done. The content is quite engaging and well presented, and the questions are quite pertinent to everything you're doing as well. All right. So, and yes, again, you'll get access to those. So you'll have an email in your inbox today or tomorrow. If by tomorrow night or Thursday morning you don't have one, then get in contact. It'll go through to the email that you signed up with. But that brings us to the end of today's course. So was there anything waiting for the end to start with questions, Jack?
That is a great question. I think there are a couple of potentially more technical questions, which it might be best to discuss in the forums later on so that there can be some more detailed kind of answers actually given. There were a couple that honestly I particularly find really interesting, which are most about security and cloud security type of thing. So there's one from quite a while back asking, how can organizations minimize the security risks present with deploying data on the cloud? Even if the data is hosted on a private cloud, it can still be easy for malicious actors to encrypt and breach confidential information on the cloud and therefore obtain the private key to gain access. And how can cloud software providers, e.g. Azure or AWS, confidently say all security risks are minimized, which we know in IT cannot be possible? So I find that really interesting. And it's, maybe we don't need to go into the super intense technical kind of side of it, just being conscious of time, but what sort of, what sort of feelings do you have around cloud security?
Yeah, so this comes back, especially when you look at AWS, they have a basically an engagement model of the way that you architect applications, but also where the responsibility lies for certain things. So the physical security of your equipment is AWS's responsibility. Keeping certain managed environments patched, up to date and safe from the environment is also their responsibility. So if you're using a managed service such as MySQL or something like that in their platform. But the responsibility, whether it's in a cloud environment, whether it's in your own data center, whether it's sitting under your desk at home, the responsibility lies with the owner of the application for the overall security and compliance of the application. So you can't, it's one of the reasons why I said that the bad reasons to move to cloud is to avoid compliance or regulations, because you're still personally responsible for that. You can't abrogate your responsibility for needing to deliver or manage for those. And that always requires careful planning. There's a lot of technologies and capabilities that are available with access management and identity management and the ability to lock things down from a cloud perspective. And many things that by default in the physical or data center world that would be by default not very secure are by default secure in a cloud environment. But you can open things up. You can have human level problems of dealing with security, but the way that you manage that security is still the responsibility of the organization and the application owners. And cloud can absolutely help with that. You can end up with an environment which is quite secure in a cloud environment. But again, the risk is the risk and responsibility is with the client for that, on how you deploy your application.
Great, thank you. I will just drop in as well that we have closed the Q&A on the Q&A chat on Zoom, but there'll be plenty of time to have as many discussions between everybody with all of their input on the online discussion forums, which you can find at learn.itmasters.edu.au. Thank you, Kit, for just popping that in the chat just now. Let's see, are there any other topics that is there a topic, Tim, that you would particularly like to answer a question on? And then I'll find you a question related to that topic.
Let me just have a quick look through here. So one of the questions here is, what are your thoughts on moving SCADA systems to the cloud? And this is the one, so just for those that don't know, SCADA systems are, rather than IT systems, they're OT or operational technology. So the sorts of systems that manage train lines like metro trains in Melbourne, or I worked at Melbourne Water, and we had electronic systems managed by computers for doing things like managing floodgates on dams and stuff like that. So as you can imagine, on train lines and dams and that sort of thing, these sort of systems are incredibly important to keep secure, highly available, that sort of thing. So the issue comes down to what type of system. Because I know I've done some work with metro trains around talking about their environments. Their plan for the future is they're going to continue to have their own data centers to manage their SCADA or OT systems for those sort of environments. Moving to the cloud for people becomes difficult, especially when you're looking at systems that need to be physically close to the environment, because you can't afford to have an outage on a system that's controlling a sluiceway for a dam, for example. So very much a case-by-case basis, but you need to be confident that the technology can support the actual changes that you put in place. And that's when you've got those sort of systems that need to be close, it's one of the problems we see. As well, a slight aside from the SCADA systems is the OT systems that you might have in a manufacturing plant. And in that sort of situation, we see a lot of systems continue to be built on site, because if someone digs through an internet conduit with a backhoe outside a factory and the internet's offline for 3 weeks, the whole factory doesn't shut down. You can often still run factory systems with local compute capability rather than needing to have cloud capability. So these are the sort of things that that the architects, planners, executive management, strategy people, and things like that need to take into account when they're looking at potentially migrating platforms to the cloud. Not only the cost and robustness, but the systems that they're interacting with as well.
Great, thanks.
And just a final one
off the
back of just a question from Steve, that could you please describe what you mean by native cloud or cloud native? So when we're talking about cloud native for applications, it's applications that are using the capabilities of the cloud environment as it stands. So using the ability to grow or scale the application using the components such as built-in databases, and that you're not manually building individual components for your application. So it might be a microservices application, it might be built on containers or serverless, but it's using the capabilities and the API level access for deploying and managing the application in an ongoing basis.
Awesome.
Cool.
That's really, really great. Are there any other in particular that you would like to answer just in the next, 2 to 3 minutes? And then we can finish beautifully and perfectly on time.
Yep. So one, I always like ones that are prefaced with sorry if this is a stupid question, because they're most often the ones that that really help hit a point from a learning perspective, because they're the sort of question that that many people don't ask because they might think is obvious or something like that. So a question from Mac, it says, sorry if this is a stupid question, haha. Is there a decentralized alternative to cloud solutions? If not, do you foresee any development in that space? So this is one of the areas that I work on in my day job as well. Because it's absolutely decentralized cloud. So from AWS, Azure, GCP, and other cloud delivery networks, there's what's called edge sites. So we have, when we go into AWS or another hyperscaler, you can choose data center locations from around the world, right? So all over the place. But if you go in and have a look at their edge locations, there's like 3 times as many sites that you can get to. And again, this is to provide low latency access to to compute or storage capability to end users, especially for accessing things like content delivery networks. So content delivery networks are the way that we get access to all of the static images that are sitting on the Amazon sales website, everything that we're accessing from a perspective of the when we're accessing Netflix or Amazon Prime or YouTube, we have edge locations providing all of that sort of capability. What I expect to see in the future as well is the ability for edge locations, again, dealing with telecommunications, the ability to have some compute power broadly available, hosted by a telecommunications company as cloud providers for very small scale applications, low latency applications that might have some storage behind them or something like that, but provide very low latency access time for gaming or one of the other type of things that we spoke about before.
Great. And actually, I need to just issue a slight correction. I said that we would finish at 9 o'clock, but actually we are able to continue on for about another 15 minutes. So Tim, if you are able to, would you like to work through the questions just kind of in chronological order, the ones that are currently in there?
Yeah, sure. Yeah, cool.
Fantastic. Thanks so much.
All right, so this one from anonymous attendee: are cloud-based solutions prone to single point of failure in cases like DDoS? So DDoS is distributed denial of service, so a type of attack where you have what you term as zombies out on the internet that send traffic at a site. So cloud-based solutions can be, if you have an individual server serving something out, or if you architect something so that you've got all of your servers coming from one site and that you have a load balancer or something like that in front of it, it's possible for your application to get taken out. So there's general capability that within AWS that it won't affect anyone else, but your IP addresses that you have the application sitting on will be made unavailable. But again, that comes down to how you architect your application, because one of the things that we have available is a whole bunch of platforms and capabilities within hyperscalers, such as the ability to avoid DDoS attacks. We can either distribute our application widely using something like CloudFormation. We can utilize a CDN, content delivery network, to make sure that, again, we're widely distributed and we can't be easily attacked. And there's security controls that we can put in place to protect us from it as well. So if we want to make sure that we're not taken off, we can absolutely architect, design, and implement from an engineering perspective to avoid that. So question from Rex: is it possible to host the application in cloud while DB to be hosted in own environment DC due to data privacy issues? Will it also stir up other data security leaking privacy issues with the connection? So first of all, it's absolutely possible. Now, one of the things that we're looking at always, though, with migrating applications to the cloud is looking at the latency between certain application points. So for example, if your application components are written such that they every time they need to pull an individual piece of information back to fill a large table that goes through to a website, they do an individual query. You might have a latency link between the cloud service provider and your own data center of 50 milliseconds. And so that means that you've got 1/10 of a second as the round trip time. And if you're putting 1,000 things onto a page, you're then all of a sudden waiting 100 seconds for the page to come through. So first of all, with that design, that would be my major concern around dealing with latency between those two sites for such an important link between the database and the application. But will it also stir up other data security leaking privacy issues with the connection? If you're already connected to the internet, most likely not, because the most likely ingress point is through that front door, right? So, or actually the most common ingress point is from someone that's already on your own network. But getting access to that from external, there's actually more tools and capability from a security standpoint for your web servers to be sitting in a hyperscaler or cloud environment than there are in your own environment. So absolutely, you can build something that's exactly as secure in your own environment with all of the tools and capabilities that they've got in the cloud, but the cloud makes all of that very easy. So I'd say it's possible, but I'd be really wary around the application pattern that you're using of having physically separated application and database components. Question from Azara Ambrose. What security measures and improve the element of trust for all the content a private company could move to the cloud? So the element of trust really comes down to what's meant by that. If your internal staff are concerned about the level of trust or security in the cloud, that's one thing. But if you're looking from the perspective of client data, that's quite different. So you're able to build what's termed as PCI compliant applications in the cloud. So that's you're able to guarantee that personally identifying information, or PII, is not made available to any third parties as part of the way that you deploy applications to support that sort of capability as well. We can build applications that are compliant from an international standard with things like GDPR. So this is the European standards for how we deal with individual privacy for deploying applications, making sure we don't leak or spill any information from those. So again, it comes down to how you're deploying the application and the patterns and capabilities that you do for managing those applications are available to you, and in many cases easier to access from a security perspective than they are in using your own personal environment. From a trust perspective, I would say having a look at the types of organizations and the reference use cases of other large organizations in the type of industry that you're looking at that are already heavily using the cloud for the type of data that you're looking at. From Anup Sood, what are your comments about NAS? How is it different from IaaS and or PaaS? So I'm not sure exactly what NAS stands for in this context, because there's a whole bunch of as a service platforms. I'm assuming that it's network as a service. And when we're looking at that from a cloud perspective, we've got private networking, the ability to build software-defined networking within our cloud service provider. So this again provides very much the plumbing and the way that our application flows through the environment, and also is an important part of our security stance and information that might be coming from our private data center in the back end as well. So it's very much a supporting technology of those other things. So we can't have infrastructure as a service or platform as a service without having some sort of network as a service that it can run on, except in some particular use cases. Question from Leo. Is it possible to use microservices to deal with AS400 type systems instead? Yeah, absolutely. So you can absolutely build applications that utilize microservices on AS400. There's nothing technically stopping you from doing so. The reason that we don't is because there's nothing that makes AS400s better for delivering that than standard Linux. Right? So if we deploy an application on standard Linux, there's a large range of people that already know how to use it. We have a large number of containers from Docker or other platforms that we can utilize to rapidly get access to application stacks. And there's all of the open source applications are built Linux first, the way that any new technology is built out. So we can absolutely build the same sort of technology on AS400, but it would take longer. It would likely be less secure, and more expensive in the long term from a development perspective. And then we would also need to have it running on AS400s and paying IBM big bucks in the back end for that as well. And we've got a last question from Douglas. In a cloud environment, each provider has access controls and entry points. How do you determine in a multi-cloud environment access controls? And is that managed under the provider for your IaaS across providers, or does it need to be managed by each independently by the customer, i.e. yourself? So a bit of both. So we have some default stance of the way that we can deploy IaaS or components, S3, which is the storage environment and things like that. So, and we have some default secure deployments of how we do so. And we have multi-layers of security that we can provide to it as well. So there's tightly integrated identity and access management with all of the hyperscalers. So you can have very granular access control, and you can have policies that are applied to everything across the board. So we can create role-based access to certain systems and build security around people having access only to do what they need for their job function, rather than having a bunch of people that have got godlike access to the entire environment. So building a new cloud environment from the ground up in a highly secure stance of making sure that not even the administrators have access to everything across the board means that we'll end up with the more secure environment. Because again, a lot of the risk for many organizations comes from internal staff rather than externally. So the risk is not just or not mainly around people stealing data, but more so around people doing mistakes, people accidentally deleting things that they shouldn't. And if they don't have access to delete or drop your production widget table or whatever it is, they won't be able to do it. All right, so we want to, so that's important from a security standpoint. So all of that capability and fine-grained access control is absolutely built in, but so is you can have NACLs, network access control lists. You've got security groups for providing essentially firewall control type access and other controls that we can have in place for making sure that internal and external actors can only get access to what they really need to. Okay, no more questions. We got through them all, Jack.
Yes, great. Thank you so much, Tim. Thanks everybody who has stuck around, and belated thanks, I suppose, to the people who have had to drop off. As we discussed earlier, this will all be available online at learn.itmasters.edu.au within 24 hours. So if you missed part of it, you can come back and have a look at what you missed, or if you'd like a refresher, if you'd like to tell your friends, family, colleagues, etc. about it, it is not too late for them to jump on board with the short course either. Yeah, thanks so much, Tim. That was extremely informative. Looking forward a lot to seeing you back here next week. As I said earlier, it will be running at 7:30 p.m. Australian Eastern Daylight Time, or, the regional equivalent of that for wherever you are in the world. Yeah, thanks very much, Tim. Really
thanks so much, Jack.
This.
Thanks, Hannah.
Cheers.
Thanks, Kit.
Yes, thank you very much, Hannah and Kit. I'm going to stop the recording now, and have a lovely week, everybody. Enjoy exploring the online environments.